Today we're doing the laws of exponents. Dum, dum, dum. We can all tell that I have watched. Keep the chat lesson related, guys. I gave you this warning. We will kick you out. Where are your classes, guys? Don't ask complicated questions. Okay, Simone did say you were gonna ask. Guys, okay, let's go through the rules again just to see if you guys remember. It's complicated, guys. I have a love-hate relationship with my classes. So the first one says it's the product rule. So if you are multiplying, that's what product means, isn't it? If you're multiplying and we have the same base, that is very important. You have to have the same base. Then you keep the base and you add the exponents. So that's rule number one. I think it's pretty straightforward. The second one is the quotient rule, guys. Quotient means divide. Once again, we have to have the same base. We have an A, we have an A. So you keep your base, which was A in this case, and we do what? We subtract the exponents. That was supposed to be a different color, and now it looks terrible. There we go. Haha. You subtract the exponents, okay? Power of a power, it means exactly that, guys. So you have one power, which is the M, and then you have a power of that power, which is a N. So in this case, you essentially have two exponents. In this case, you will multiply the exponents. Okay, Mn means M times N. So you will multiply these exponents. And then the fourth one is power of a product. AB. If you just write AB, this is the same as saying A times B. Okay, so inside the brackets, we have an A times B, all raised to the same exponent, which is M. So in this case, you will have to distribute. It's sometimes called the distributive law of exponents. You will distribute, and then A has to get an M, as well as B has to get an M. Take notes, guys. Take note. These are different bases. Okay, so it's not the same as law number one. Law number one said the bases had to be the same. So in this case, these are two different bases, in which case you will have to distribute the exponents. Law number 5 is the same as one we just did. In this case, we are just dividing instead of multiplying. So same case, we're dividing two different bases, A and B. So you have to distribute. So A gets M. Oh, don't ask me how I just did that. Magic. A gets M as well as B gets M. Okay, zero exponent rule. And I'm going to do it in rainbow colored because it's like a magic law. Anything to the power of 0 is 1. That was a horrible magic color and I'll never use it again. Let's see. That. There we go. Anything to the power of 0 is 1. Then we have your negative exponent rule, guys. So you have a base to the power of a negative number. In this case, you will do the reciprocal, as in you will swap them. So a to the n and negative m, like this, is the same as a to the negative m over 1. So reciprocal means swap them. And once you swap them, your exponent becomes positive. Are we all with me? We are very quiet. And now I'm like, am I talking alone? Is everyone still here? Are we all still with me? Did I say anything that didn't make sense to me? Like, no. There we go. Thanks, Zukanye. And I see your thumbs up in the reactions. Thank you, guys. Beautiful. Okay. So I'm going to ask you again. Would this rule 2a cubed b squared c 0? What do I do over here? Pamela? Pamela's hand like, poof. Pamela, hello. Okay, in the meantime, in the chat, what do I do with that, guys? We have a power of 0. So tell me what the final answer is. Yes, that's correct. Oratile. Tell me what the final answer for this thing is. Dumiling says 1. I need more people to answer me. Vanna says 1. Pamela is still not unmuted. Unam says 1. I hope we're paying attention here. Everybody's saying 1. Guys, you need to ask yourself an important question. The important question is, who does this power of 0 belong to? Oh, Jonathan is onto something. Who does this power of 0 belong to? The C. So are we changing our answer? Yay! We're getting somewhere. I need more people to realize what's happening here. So only, I'm a bit late. It's okay. Welcome, Pamela. Yes, so only the C goes away, guys. So it's A cubed, B squared, and this turns into times 1, but then it's just gonna remain as A cubed, B squared. Okay. I hope. Simone, I think Pamela can't hear. I think that's the problem. She's not connected to sound. She probably missed the whole join audio part.
Okay, no problem. I'll message it directly.
Okay, thank you. Okay, guys, so I wanted to show you this because a lot of teachers catch you out with this question. Remember to check where these apply, including with the negative exponent. If you have a bunch of numbers and one of them has a negative exponent, be careful. Do not just be quick to do the reciprocal. Check who that exponent belongs to. Okay, now we can do our applications. Let's do our simple, quickly applications. I need someone who's going to do A, B, C, and D with me. Separate people, obviously. Separate people, please. There we go. Minence's like, boom. Hi, Minence. Minence ran away, never mind. Tato.
Hey, ma'am.
Hello.
Ma'am, A is going to be 2 plus 4.
Which is?
Yes. It's going to be 6.
6. And how much is 2 to the power of 6, Tato?
64.
64. Thank you very much, Tato. Beautifully done.
Yes, ma'am. Thank you.
Dumeling. Dumeling, do number 2 with me, number B.
Hi, ma'am.
Hello.
We're going to say 2 to the power 4 minus 2. I mean to say 3 to the power 4 minus 2.
The answer is?
Okay. The answer is, can I calculate?
Dumeling, what's 4 minus 2?
4 minus 2 is 2. So 3 to the power 2 is equals to 9.
Thank you very much, Dumeling. Beautifully done. There we go. Sia, are you doing number C with me?
Yes, ma'am. 3 to the power 3 to the power 4 equals to 3 to the power 4.
Are we
Plus
multiplying? Be careful. Oh, there we go. 1 plus 3 to the power. But how much is 3 to the power 4, Sia?
3 to the power 4 is 1. But because we add the plus 1, it will go to 2.
Thank you. Thank you, Sia. Beautiful. Okay, we're on number D. We're going through these at the pace we are supposed to. Hello, hello.
Hi, ma'am.
Are you ready?
Yes.
Let's hear.
So, ma'am, it's going to be 2 to the power 3 times 2.
You guys know your rules well. Which is 2 to the power of?
6.
Which is how much?
64.
Thank you very much. Beautiful. Okay, guys. So I know someone's gonna ask, and I'm surprised nobody has asked so far. I know someone's gonna say, "Man, I did this in a different way, but I got the same answer. Is it wrong?" So I want to point something out to you guys. So the instruction, which I should have read with you, the instruction said use the laws of exponents. Of course, I'm gonna highlight terribly after highlighting beautifully. Like that, never mind, it's happening again. So what does that mean, guys? It means, for instance, in A, I want to see this, okay? So if you went and said 4 times 16, you are gonna lose a mark. But I specifically ask you to use the laws of exponents. So your first mark is gonna come from using the law of exponents, and your next mark will come from the answer. If you only write the answer for me, or you don't use the laws, you're only gonna get 1 mark. We understand? Same here. I want you to show me that you're subtracting. So it's either there or there. So I'm gonna mark either one of the two and then the final answer. But if you don't show that you know how to apply the laws when I asked you to use the laws, we are losing marks. Let's see what number C. Probably some of you are like, well, where did we apply laws of exponents for number C? Yeah, I want to see that you know that anything to the power of 0 is 1. And I say plus 3 to the power of 4 is 81, and you just add them. You cannot add the exponents here because we are adding, okay? Don't let that catch you out. We are adding, we are not multiplying. So you cannot add the exponents. And then number D was pretty straightforward. It was power to a power. You get your mark for showing that you know you must multiply. You get your mark for your final answer, which is beautiful. Now we have E and F quickly. Who's gonna help me with E and F? Hands up. Anyone? Hands that are already up. I don't know if you want to help me or if they were up before. Mpo? Is Mpo going to help me? Dun, dun, dun. I need to stop watching my names. What are they saying?
Hi, ma'am.
Do you want to help me with E?
Okay.
Cool.
So what I did was I first worked inside the bracket by saying 5 times 2, which gave me 10.
Mpo, remember I said I just gave you a whole speech about applying laws of exponents, right?
Yes.
So what did we have to do to those two?
Distributed.
Distributed. So distributed for me, then end up with, you're gonna get the same answer, I know, but I asked for the laws. But tell me, when you distribute it, what's gonna happen there?
So
It's
you're
gonna
going to say
become,
of 2 times 5 to the power of 2.
thank you. How much is 2 to the power of 2?
4.
4 times,
25.
which is,
Which is 100.
Thank you very much. Beautiful. Thank you very much. Okay, Impostor hasn't unmuted, so I'm gonna choose someone else to help me with F. Whoever is laughing, you better not be laughing at my facial expressions. I see you guys. I see. Okay. What's happening in the chat? Wanted to answer. Oh, okay. Okay, I understand. Let me lower your hand. Okay. Let's see if Kavila wants to help me with F. Nope. Kavila is gone. Let's see if Kimora wants to help me with it. Kimora is clapping and celebrating. So Kimora, I need your energy right now. Kimora vanished after I said that. Itumeleng, do you have a question or are you helping me?
Can I help? Okay, ma'am, we're going to say, we're going to distribute the 3. So we're going to say 2 to the power 2 plus 3 times 7 to the power 3.
Remember, Itumeleng, when you distribute this 3, and it already finds the exponents there. This is power to a power. You see that?
Okay, ma'am.
We're not gonna add. What are we gonna do?
We're going to divide. We're going to multiply.
Beautiful. So then it's gonna be 2 to the power of what?
So I'm going to say 2 to the power 2 is equals to 4. 4 to the power 3 times 7 to the power 3.
Remember, we have to multiply these exponents. Oh, that was a terrible circle. We have to multiply these. So it's 2 to the power of 2 times 3. How much is 2 times 3?
6.
6. Then it's times 7 to the power of 3. Okay, then what?
So 2 to the power 6 is equals to 12. Then 7 to the power.
Not times 6. Be careful, not 2 times 6. It's 2 to the power of 6. So it's 2 times 2 times 2 times 2, 6 times.
So 2 to the power 6 is equals to 8. Then 7 to the power 3 is equals to.
Wait. 2 times 2. How much is that?
It's 4.
Times 2
is 8.
Times 2
is 60.
Times 2
32.
Times the last 2.
Oh.
So the answer is
64. Sorry, ma'am.
64. It's okay. And then what's 7 to the power of 3? You do the same thing, but 3 times.
Okay, 7 to the power of 3 is equals to 343.
Beautiful. So then what's my final answer?
So we're going to say 64 times 373 is equals to
it's
343, ma'am. 64 times 343 is equals to 21,952.
Thank you very much. That is our final answer. Okay. Thank you to everyone who helped me. That went quick. Now, I want you guys to tell me which one of the following are true. If it is false, give me the correct statement. Let's start with A, B, and C. A. Is A true or false? Radila says false. Keep sending your answers. Pamela? If you're on your phone, then swipe and press speak. Pamela? I see you guys saying false. I see you. Okay, so it seems like we all agree. Hi,
hello, ma'am.
Hello.
Oh, ma'am, 6, for A, ma'am, 6 exponent negative 1 is false.
False. That is true.
Yes,
what is it supposed to be?
Actually, ma'am, I haven't learned about negative exponents.
Remember,
No.
there is so if you have 6 to the power of negative 1 over 1, reciprocal means swap them. So take this one to the bottom, that one to the top. What will the answer be? No, Chelsea, no calculators, please. Thank you. So it will be 1 over 6 to the power of 1, but we don't write to the power of 1. Okay. Do you understand how this works, Pamela?
Yes, ma'am, I do.
Beautiful. So it is indeed false, guys, because you're supposed to find the reciprocal. You can't make the number negative. You're supposed to find the reciprocal. Chelsea, please stay away from your calculator, because for stuff like B and C, what's going to happen? Ooh. Zukanya says B, it's true. Oh, let me hear what everyone else has to say. What does everyone else has to say with B? Siamtana says true. Hello, Ayabonga, Chelsea. Tabitha said false. Notola says true. Nivoya says true.
Ma'am,
True, yes.
I'm really confused now.
Yes, just listen and see what we're going to do, okay?
Okay.
Oh, also, Pamela, this is not the actual exponent course. This is just revision. So it's possible that you have to watch the original courses that are on the website. Yes, you may, Tabi saying that's here.
Okay, ma'am. So the reason why I say it is false is because, so what I did was the x is the one that's negative, right? So what I'm gonna do is I'm going to put it underneath the 3. So I put 3 over x to the power of 2.
And that would be beautiful. Because you are brilliant. So this was false. Thank you very much. Guys, you didn't listen in the beginning when I said, look who the exponent belongs to. Do you remember I said that? I just said that 2 minutes ago. Okay. Yes, guys, so this is false because the negative only belongs to the x. There we go, Zukanya. All we want you to see the mistakes. So your teachers will never catch you out on this, né? They'll never catch you out. Because now you'll know that if the exponent only counts for one variable or one number, the others are not affected. So if your teacher tries to catch you out, be like, ha, seen this trick before, I'm not gonna fall for it. Okay. And on that note, is C true or false? Oh, yes, it's true. Tammy says true, true. Oh, we listened. We listened. Is anyone who's confused about why C is true? We should all now see why C is true. This is so refreshing, guys. Like after this, I can go to bed. That's how much you guys make my day. Tato, please raise your hand so we can talk about what's confusing you. Itumeleng as well. Either Tato or Itumeleng or type it in the chat, guys, so that I know where exactly I lost you. Remember, this is a revision course. If you were not here for the original exponents course, then this will be confusing. So I suggest you first go watch those. Remember, lessons are recorded and they're on the website. But if you were there and you generally still are like, I don't know what's going on here, then please type it in the chat and let me know where I have lost you. Okay. In the meantime, everyone else can figure out, I don't know why the screen is moving. Minjik can figure out, okay, no, we don't have time for these. I need to do equations at the bottom. Guys, I'm giving you 5 last seconds. 4, 3, 2. Okay, Tata has sent me a message. So remember, when we have 3 to the minus 1, x to the minus 2, this is over 1. Remember, any number is always over 1. So if you just have a 2 and you put it over 1, it means the same thing because 2 divided by 1 is still 2. So if you want to do this in 2 steps, we can. Okay, let's first start with the x. It's going to be 3 to the negative 1. The x goes down, it becomes positive. Wonderful. And then from here, we still have a negative exponent. So then what's left at the top? It has to be 1. It can't be 0 because then you're going to just annihilate and cancel this whole equation. So it's going to be 1 over x squared 3. Well, okay, we'll swap them around. Don't write them down. That wasn't a good idea. 3x squared. Do you understand now? Like that. Do you understand now, Tato? I hope I've answered your question. So that one is there because it's a reciprocal. Okay, it was over 1, but now it's going to be 1 over because you swap them around. You're welcome. But I'll be saying we're not doing them. We're going to, okay, no, actually we do have time. We do have time. What are you saying? You're going to do?
Ma'am, so I was asking if I could do D.
D. Let's do D.
So firstly, I'm going to distribute the -2, right, by saying a to the power of -2, b to the power of -2. And then after that, since they're negative, I put 1 over a to the power of 2, b to the power of 2.
So this was true. Thank you very much. Let's see what else we have here. We can do the same thing here, guys. It's the same question over and over, basically. You distribute them and you swap them. Okay, thank you very much, Ndayisen, for showing us how to do that. So I hope you guys sort of understand now what's going on with these. I hope you guys understand. I love it. Okay, now let's do some proper work. Okay, I'm tired of doing baby stuff with my grown learners. Let us apply all of these rules. Tyson hand is still up, so I don't know if Tyson still wants to work with me or what. Come on, guys. Tyson can't be the only person answering. Would you like me to do the first one? Yeah, then you do the rest. And then, guys, anyone else wanna try? Tyson, don't put your hand down, please. Keep it there. Oratile says no, so you don't want me to do it. I don't know what that means. Excuse me, Tyson and Pamela. I see your hands, guys. Don't lower them. We can do it. Yes, let's do it. Okay, it's fine. I'll pick in Tyson. Pamela, you'll finish off. So we're gonna do some of it and give Pamela a chance to finish it off. Is that fine?
Okay, ma'am.
So where would you start with this?
So firstly, I would start off with the brackets first.
Okay.
So firstly, I would break up the bottom bracket, the one that says bracket A, B, C to the power of 2, close bracket. So I would say A to the power of 2, B to the power of 2, and C to the power of 4.
Okay, let me first write the numerator. And then you're gonna say A to the power of 2, B to the power of 2, and C to the power of 4. Beautiful.
Yes.
Times.
And then after that, I was gonna say, at the top there, I was gonna say, A to the power of +2, since negative times the negatives are positive. And then B to the power of -3, C to the power of -1. Yeah, and then I was gonna put it over A to the power of 0, B to the power of 4.
There we go. Okay, give me a next step.
So then now the next step was to match like the same thing, the same variables, like the A to the power of 2 and the A to the power of 0. Since they're dividing, I would take the A to the power. Okay, let me do the AB to the power of 2 with C first. So I would say A to the power of A to the power of 1 over A to the power of 2. So then I would take that A and minus it. So I would say A to the power of 1. And then for the B part, I would say.
Remember, typing it's always minus denominator.
Okay. Okay.
That's going to be -1 because there was a 1 there, right?
Yes, ma'am.
It's 1 minus 2, so it's
-1. Okay.
Let's move on to B.
And then I'll say B to the, and then it's B to the power of 0, since B to the power of 2 minus B to the power of 2 is 0. And then I would say c over c to the power 4, which would give me negative 3.
Beautiful. Times. Now on this side.
And then times a to the power 2 over a to the power of 0, which would give me a to the power of 2.
Mm-hmm.
And then the b side, negative 3 minus 4 would give me negative 1. I mean 1.
Mm-hmm. Be careful. Negative 3 minus 4. So they're both
Oh,
negative.
yes.
So it's going to be?
It's going to be negative 3 minus 4, which is negative 5.
There we go. Babalo has helped you in the chat.
Negative 7.
There we go. Close. And then C's, there's no C in the denominator, so we just...
So you're just going to leave it like that.
Okay. Next step.
And then the next step, you don't you make the stuff that are not positive. So you
can
put
do
the
that.
over.
You
so you
can,
say,
but I suggest you deal with this multiplication first.
okay. So I would say, I think this is right. You just say a to the power of negative 1 times a to the power of 2, which is a to the power of negative 2.
Remember, when you multiply, you have the same base. What do you do to the exponents?
You add them.
No.
So it's going to be
Here we
a
go.
to the power of 1.
Beautiful. B.
And then you're just going to say for b, you're going to say b to the power of 7.
0 minus 7. Remember, you're
0
adding.
minus 7, 0,
It's
0,
0 plus negative 7, which is 0 minus 7. So it's negative 7. Here we go.
Okay. And then for the c, I would say c to the power of negative 4.
Yes, negative 4. Now it's easier to deal with the negative exponents. Do you see that?
Yes, ma'am.
So tell me what's
So
going to
then
happen with these.
now you put them over. So then now you're going to say a to the power of 1 over b to the power of 7, c to the power of 4.
Beautifully done. Absolutely beautiful. Okay, I love it. Okay, guys, you guys were awfully quiet. Let me check in. Thumbs up, thumbs down. How did that question go for you? Remember, if someone else is helping me, you are supposed to be doing it on your own there to see if you understand. Oh, I see a lot of thumbs up in the reactions. But for 80 people, I definitely need more thumbs up, guys. I need more thumbs up. There's 78 of you in here. I would like more thumbs up or thumbs down, whatever. If you don't understand, thumbs down so we can talk about it. Now we're talking. Abisha, where did we lose you? Raise your hand, my darling, so we can talk about it. There we go. Hello, Abisha.
Hi, ma'am.
Where did we lose you?
I got lost on the part where you got your -7 and -4.
So the part where I highlighted pink.
Yes, ma'am.
Okay, remember, Abisha, when we are multiplying, what do we do to the exponents?
When we are multiplying, we add the exponents.
Yes. So let's start with B. So we had 0, and you said we add, right?
Yes, ma'am.
So it's a plus, but we are adding a -7. We're not adding a +7. Do you see?
Yes, ma'am.
So then we have this problem over here. A positive and a negative give you what?
A positive and a negative give you a negative.
So it's going to be 0 minus 7. How much is 0 minus 7?
7.
0 minus 7?
0.
Remember, you're starting at 0. You're going into the negative side, right? You're going that way because you're subtracting.
Negative 7.
There we go. So do you see where that negative 7 comes from for the B?
Yes, ma'am.
And then let's do it with C as well. With C, we had negative 3 plus negative 1, right? We're back to this problem here with the plus minus. So you said a positive and a negative give you negative. So we're going to have negative 3 minus 1. Back to our number line. If you're at negative 3, this is going to be negative 2. That's negative 4. When you subtract, you go that way to the left. So negative 3 minus 1 gives you?
Negative 4.
Negative 4. Do you see now where we got them?
Yes, ma'am.
Beautiful. I love it. This is lovely.
Thank you, ma'am.
You're welcome. Okay. I feel like we're doing well. We're doing well, guys. I think we have it in us to do one more of these, and then we'll go to our brain break. These are too easy. Okay, we can do this one. We can do this one. I'm gonna name it B. Then we can go to brain break. All right, guys, we need someone who's not typing. If you're not sure, it's fine. We will work on it together. I need someone to please raise their hand so to do it with me. Things are killing us. Come on, guys. Anyone? Even if you're not sure, Intervison got the notes before. Intervison, do you have my one note? Maybe Intervison has the notes. You know that. Let's do this. Yay, Tammy.
Hi, ma'am.
Hi, you're gonna do this with me?
Yes, ma'am.
Beautiful. Let's do it.
Okay, ma'am. So first you're gonna distribute the 2 in the numerator to the bracket. So you're gonna say 15. And then you're gonna say a to the power of 6, because 3 times 2 is gonna give you 6. And then you're gonna say times a to the power of 10, because 5 times 2 gives you 10. Then you're gonna say b to the power of 5. And then you're gonna say over 5 a to the power of 14, because 7 times 2 is 14, and b6.
Beautiful.
And then, ma'am, next thing you're going to do is you're going to divide. So you're going to say 15 divided by 5, which is going to give you a positive 3. And then you're going to say a to the power of 6 minus 14. Wait. Ma'am, there's something I didn't do. Yes, ma'am. So you're going to say a to the power of 16, because 6 plus 10, it gives you 16. You say a to the power of 16 minus 14. And then you're going to say b to the power of 5 minus 6. And then, ma'am, you're going to say 3a to the power of 2 and b to the power of negative 1. And, ma'am, your final answer is 3a to the power of 2 over b.
Beautiful. Beautiful, Tammy.
Okay.
Beautiful. See, guys, you guys can do this. When I keep calling you 100 times, it's because I know you can do this. But anyway, hands up for the brain break quickly. And Taviseng deserves a brain break because Taviseng has been answering the whole time. Taviseng, are you ready?
Yes, ma'am.
Beautiful. Let's see what your question is going to say for the brain break. Let's see if my computer can cooperate and scroll faster than a snail. Here we go. Would you rather carry a flip phone? Have you seen those old ones? Do you know the Motorola ones? Not these new ones.
Yes.
Would you rather carry a flip phone or use a desktop computer? Like those big ones you can't walk around.
I think I'd use a desktop computer because, like,
You want a smartphone.
yeah.
Have you seen, you know how long that desktop computer takes to connect to Wi-Fi? Not even, you didn't even connect Wi-Fi. It wasn't wireless. It was that wire. And it goes, are you sure?
Yes, ma'am.
Okay. If you've committed,
But like a flip phone, it doesn't even connect to Wi-Fi. That's the thing.
it doesn't even have WhatsApp.
Exactly.
People who are saying flip phone are gonna be calling every day. Maybe they have airtime, it's fine. Okay, Minentle. How's Minentle
Yes, ma'am.
doing? There we go. Here's yours. Would you rather only charge your phone once a week or not have a camera on your phone?
Charge my phone once a week.
Whose phone are you gonna take pictures with?
No, actually, I have a camera.
You want the camera. Oh my goodness. Because guys, whose phone must you take pictures? You guys don't want memories. You just want to charge phone. Yeah, that's all you want. Wow. Hectic, guys. So you guys want to charge once a week? I can't believe it. But it's fine. It's fine. Load shedding most. Yeah, but if you only need to charge once a week, it's not gonna affect you because your phone battery will just last. Sure. Okay, guys. Bunta, you ready?
Hi, ma'am.
Hello.
I'm ready.
Let's see. Would you rather have to listen to only Justin Bieber or only Ariana Grande for the rest of your life?
Would I rather have to listen to Justin Bieber or Ariana Grande? I like Ariana Grande more than Justin Bieber. So it's Ariana.
I can't
Ma'am?
believe. Yes, guys, Justin Bieber's a vibe.
Justin, ma'am, he fell off, ma'am.
Who
Ariana,
cares? The old ones.
ma'am, Ariana, like
No.
her music is very nice.
You know Ariana's gonna hit your ears one day. That's all I'm saying, and you know why.
They're making us feel old.
Ariana is gonna but seriously, the voice in earphones, guys, you're gonna think of me one day when you can't say, hey guys, do you know would you rather words? It's either this one or that one, not any other one. So you must choose between the two that are on the screen. You can't just bring your own choice and say Drake. I said Ariana or Justin. It's fine. Narisha, are you there?
Hi, ma'am.
Hello. Let's see. No other way, guys. You can't rock on me. Would you rather be a famous rapper or a famous singer?
Famous rapper.
Famous rapper.
Yes.
So you have bars. Hey. Guys, do you know how much creativity it takes to be a rapper? I would definitely over my words. I could like, nope. Like I wouldn't be able to. Narisha, next lesson you must come with your rap. I wanna hear it. All of you who are saying rappers, I want to see your bars the next time with me. Yes, let them rap. I wanna hear. Chelsea's right. I wanna hear you guys rapping, telling us you're gonna be famous. But lately people just say weird stuff and make weird voices and then they call themselves rappers. But it's fine. Paul, it must be a maths rap. Yeah.
Hello, ma'am.
Hello. Paul, would
Okay,
you rather expired milk or rotten eggs?
Whoa. Oh.
Have you smelled rotten egg? Oh, those things are deadly.
Ma'am, they're both like they're both disgusting. Okay, I'll say milk, ma'am.
Milk. So nobody wants to
Yes.
sniff the rotten eggs. The eggs are worth it.
Cause
Ooh,
eggs, I don't want to suffocate. See, I'm trying to
that's
live.
true. Someone in the
Yes,
other
ma'am.
class said it's gonna burn your nose hairs. We don't want that. We don't want
Yes,
that.
ma'am. Yes, ma'am.
Ooh. Yeah, no, guys. No, eggs are a bit too much for me. They're a bit too much. And the smell stays in your fridge. And guys, have you ever craved egg and then you crack it into the pan and it's hot and everything? And that's when you discover that it's rotten. Appetite gone. You don't eat. It's done. I just don't eat for the rest of the day. Like, I'm cool. No, Kimura. Hey. Ugh, you guys are asking hated questions. It's fine. Let's continue. Let's continue. Let's continue. I like us really like fermented. Let's do exponential equations, guys. You guys are killing me. Okay, who remembers how to do this? Amisha and Tata and Chelsea are in the time of their lives, and I'm trying to behave. No. So this whole time you thought we were drinking expired, like I even can't. Okay, guys, let's go back to the lesson. That's enough laughs for today. Exponential equations. Who remembers how to do this? Who remembers how to do this? Tammy. Hi, Tammy.
Hi, ma'am.
You're gonna help me to do this.
Yes, ma'am.
Okay, let's hear.
Okay, ma'am. So you're gonna say 2x is equals to, ma'am. So if we put 32 in exponential law, we're gonna say it's 2 to the power of 5.
And then?
And then you can, and then ma'am, the next step we're gonna say x is equals to 5 because we have the same bases.
Thank you very much, Tammy. For all of you who are just like, what just happened? That it would be the correct answer. That will be the correct answer. And if you don't know how to put the 32 as a product of its prime factors, because that's exactly what you're doing here. You go on your calculator, you say 32, you press equals, and then you press shift, and then you press fact. Fact is the button that looks like full stop, and then there's like commas, and I don't know what's going on there. If you do that, it's going to give you a number as a product of its prime factor. So if you do it with 32, it's going to give you 2 to the power of 5. Okay. If they say no calculators, guys, you just do the traditional factor ladder. So you're going to say divided by 2, that's 16, divided by 2, that's 8, divided by 2, that's 4, divided by 2, that's 2, divided by 2, that's 1. So then 32 will be 2 times 2 times 2 times 2 times 2, 5 over 3. So you can use either method. And if once you have the same base, guys, once you have the same bases, your exponents have to be equal. Okay, because it's like me saying, let me do it at the bottom, because I know someone is sitting there like, what just happened? If I say 2 times something is equal to 10, what does that something have to be, guys? If I say 2 times something, and we don't know what that something is equal to 10, what is that something? There can only be one answer. That something is what? Okay, Pamela's hand is up. Yes, Pamela. Thanks, Chelsea.
2 times something, ma'am, is 5.
Exactly. So it has to be 5. So in this case, we just replace it with an x. So then x will have to equal 5. Do you see how these work?
Yes.
So guys, it's the same with exponential equations. If I say 2 to the power of something that we don't know, is the same as 2 to the power 5, and x has to be equal to 5. Okay.
Let me just
Okay.
try this one.
You want to do it with me?
Yes, ma'am.
Yes, ma'am.
Oh, geez, there's 2 people answering. Sorry, Fulu. Let's hear what Pamela has to say. Pamela, don't run away, Fulu.
I was just saying I'm gonna try the next sum, ma'am, the second sum. That is equals to 8 to 1.
Okay, so it's going to be 3 to the power of what?
I'm still trying it. I just made a mistake, ma'am. Sorry.
It's okay. Let me ask Fulu, because Fulu wants to answer. Yes, Fulu.
It's gonna be 3 is equals to 4. 3 to the power 4.
3 to the power of 4.
And
So
then
therefore, x is what?
x is 4.
Beautiful, Fulu. Thank you very much. I think we have time to do some more challenging ones. Let's go there. Okay, let's hear if anyone wants to help me with this. First, you have to find out what 1296 as a product of its prime factors is. Yes, we do have, and luckily this is just revision. 1296, guys, as a product of its prime factors. I know these look complicated, but they really aren't. Anyone know? Chelsea's hand just went up. Chelsea? Hello? Okay, Chelsea's mic is not working. Tabby saying, do you know what 1296 as a product of its prime factor is in the chat? Anyone? Remember how to do it? You say 1296 equals, you press shift and you press fact. Okay.
Ma'am, it's 4.
What's 4?
It's the thingy. It's 1296 is 6 to the power of 4.
Is it 6 to the power of 4?
Yes, ma'am.
Thank you very much. 6 to the power of 2x. So once we have that, we have the same basis. What can we do to the exponents?
You say 2x. You say 2 minus 4 or 4 minus 2. I think one of the two.
There's an equal in the middle. So then
So
the exponent,
don't you move the 4 and then you say 6 to the power of 4 minus 2x.
no, remember, if you have the same base on two sides, let's say you have 6 and a 6, you can make the exponents equal. Do you remember?
Yes, ma'am.
Regardless of what the exponents are. So you can say this equals to 4 because we have the same base on both sides. You see?
Yes, ma'am.
And then you solve for x. How do we get rid of this 2 that's in front of the x?
You divide by saying you just say 2. You divide by 2.
But what you do on the left?
You do on the right.
So then x is going to be
X to the power of 2. I mean x equals to 2, sorry.
Thank you. Beautiful. I'm saying beautiful. Okay. All of you who got 2 times 2 times 2 times what? I saw very different answers there. I don't know what happened. Remember, we want the same base on both sides. We want the same base on both sides. So what you can do, guys, if this gave you 2, 4 or something times 3 cubed, what you can do is you can change 6 to 3 times 2 to the power of 2x. Then you distribute. I just want to show you it's still going to work. So 3 over 2x times 2 to the 2x equals. Okay, what I'm trying to do is not working in my brain. I'll start you in the next lesson to show you how you can do it even if it's 2 different bases. Because 2, 4, and 3 cubed are a little bit different. For now, try to get them at the same base. And we're out of time. Please run the poll quickly. Someone, in case someone wants to leave and go home.